I'm Anil Kumar. Welcome to our first session on advanced functions, which is a grade 12 course in Ontario, right? And the IP students who are in grade 11 do take this. Now, I'd like you to introduce yourself one by one. Can we start with Akshat, please?
Yeah, so hi, I'm Akshit Kandiganam. I'm currently going to grade 12. I just finished grade 11 and I did functions with Anil sir, so I thought it would be best to revise advanced functions so I can do my best next year too.
Hamza, can you introduce yourself?
My name is Hamza. I live in Oakville, Ontario. I took grade 11 functions this year, and I'm going to grade 11 next year. So I plan to take it next year so I can do calculus in grade 12. And I'm planning to master the concepts because I know it's going to be crucial in the next few years when I have to learn more advanced math courses.
That's right. Mohammed, can you tell me about yourself?
Um, I'm a grade 11 student. I live in Oakville, Ontario. I haven't taken any grade 11 courses yet, but since I know the jump to grade 11 is really it's really big from grade 10 to grade 11 math, I want to get a head start and learn the concepts before I get into the course.
Can you please introduce yourself?
Hi, my name is Ankita Nayak. I'm also going to grade 12. I live here in Brampton. I go to Chinguzi Secondary School. I did take functions in November, and I did take tutoring from Anil sir as well. So I think that being ahead of my peers in my class will really help me, just because, the school model is very unpredictable. So I would like to stay ahead.
Sure, that's so nice to hear. Okay, then. So I'm assuming, as I said, that the grade 11 functions, you all have kind of fairly good knowledge, right? Based on that, we are going to start our lesson today. So I had actually shared with you one of the test papers of grade 11 functions. Did you get a chance to look at it, all of you?
Yes, sir.
Hamza, did you see that grade 11 test paper?
I saw a video that you sent yesterday.
Okay.
Is that what it was about?
Okay, because if you solve the test paper, I'll come to know what points are very clear to you and what is not, so that we could actually revisit those things before really getting moving forward with the grade 12 advanced functions. Ankita, how about you? Did you get a chance to see that test paper?
Yeah, I did. Some of the concepts were a bit unclear just because I did functions a long time ago.
Okay,
So I think revisiting them would help.
like what?
I understood the basic concept, I guess, like, exponential functions and then working with radicals, stuff like that kind of, messed me up a bit.
Okay, that's fine. That's fine. Akshay, do you have any questions?
Not really, sir. But I think it would be nice if we could revisit exponential functions once again.
Exponential functions. We'll get to exponential functions because exponential functions are not really taught in grade 11. So we'll look at it at a greater length. Okay.
Okay, sir.
Anyway, so let me discuss with you some basic concepts. Let me share with you what I have for you, the lecture which I have prepared for you, and we'll begin from there. Okay. So I'm going to share this particular lesson. Okay. So can you all see my screen? Hello.
No, we can't.
You can? Okay. Share. Okay. Yes. Now I think you can. I forgot to say. Right. You can see the screen now, correct?
Yes, sir.
Perfect. So it is advanced functions. We'll give an introduction to functions. So I'm not really getting into details of fractions, and therefore I was discouraging Mohammed at this moment, right? But Mohammed, whatever we are talking about will make sense to you because I try to, explain from the very basics, but I do not want to stay here for long. Do you understand? I'm going to move very fast after this. So first lesson will be okay for you, but then thereafter it'll be very difficult to catch up. Okay, so we'll talk about introduction of functions. Everything is related, and that is what we call relations, correct? So relation things are related. Functions are very special relations. Can you tell me how functions are very special relations? Anyone?
So they have like one output for every input, which makes them a function.
Correct. So every input has exactly one or unique output, right? So that makes it a function. For example, if I say my mother, so everyone has a unique mother, it is a function, correct? But if the mother says my son or my daughter or my child, in that case, we are not sure which child is the mother talking about, correct? So that becomes one to many relation, and we don't know exactly mother is trying to connect with which child. So it is not a function. Perfect. Did you understand this fine difference between relation and functions? So that is how we are always going to see whether a given relation is a function or not. Correct? So here is the very first example for you. I would like you to tell me if you can. Okay, so here is the example. This is called a mapping diagram, as most of you know. Is it a function or not? Hamza, can you answer this question? The mapping diagram.
This the mapping diagram, right?
Yeah.
So uh, every input has one output. No, I don't think this is a function.
Perfect. This is not a function since you see that the arrows are pointing from this place to that place, correct? So 3 is linked with C and D both, right? So it is a relation, but not a function. Correct? Very clear. Most of the time in the test papers, the arrows are always pointing towards the right side, but in the test, sometimes they make it the other way, right? So that is how it is. And as you said correctly, this is not a function. So now every element from the input is treated as the domain of that particular function, right? So this is a function of, no, this is not a function, but anyway, even relations have domain and range. So in this particular case, the elements in the input are called domain and the elements in the output are called range. So we know that 1, 2, and 3 are the 3 elements in the domain of this relation, and A, B, C, D are the elements of the range. Clearly, when the number of elements in the range is more than the number of elements in the domain, it cannot be a function, right? So that is very clear. Correct. Now, if I give you a graph like this, can you make out whether this is a function or not? Ankita, is this a function, any of these graphs?
I don't think it's a function.
Because it fails the vertical line test. So if I draw a vertical line, in that case, it crosses the graph at more than a point. So it is not a function. This really means that any point x here is related to more than one. You know, this point and that point. So there are 2 y values for this. So every input is, most of the inputs in this case, you can say, except for the one here kind of at the x-intercept, are related with 2 values on the y, and therefore this is not a function, correct? So that is how we relate functions, and now we have understood what is domain, what is range. How do we figure out from the graph or a mapping diagram whether it is a function or not a function? So based on this, I have a question for you. So I'd like you to quickly write down the answer in your notebook, correct? So it's a multiple choice question. How many of the following are functions? So we have these equations, right? So this is our equation number 1. You can say this is my equation number 2. This is my equation number 3. How many of these equations are functions? This is what you need to figure out. So you can exclude the ones which are not functions, correct? Yes. So yes. So Akshat, what answer did you get for this? How many of these are functions?
Yeah, I'm thinking 3 of them are functions because
You're
the one
thinking
with y squared.
three of them are functions, which is not a function.
I think x y squared equals to 1 is not a function.
That is correct. Now, how about this? Yes, Hamza, can you tell me, how about this? X equals to 1. What is this?
To me, if I graph this, I'm imagining this would just be a straight line, right?
It is a straight line in which direction?
Horizontal.
No. Ankita, what is this? X equals to 1.
It would be a vertical line.
Perfect.
Function.
Is it a function or no? Mohammed, are you getting it?
Yeah, I knew that it was a vertical line, but I don't know like what it means to be a function, what not.
Now you understand what it means to be a function, right? For every x value here, we have so many y values. Therefore, this is not a function also. Do you see that? So these two are not functions. And in this case, there are only two functions. Do you get the idea? X equals to 1 is a vertical line. And what you said, Hamza, was y equals to 1, right? So if I have y equals to something, that will be a horizontal line. Let's say y equals to k. In that case, that constant k is the horizontal line. So you should be very clear about it, that horizontal lines are constant value for y and the vertical lines are constant value x, correct? So very important question from test.
I have a question, sorry.
Pardon?
I have a question, sorry.
Ask.
Is there like an easy way to tell, like if we look at an equation just to tell it's not a function without graphing it, or just
Very good. Perfect. This is what I wanted. So in an equation, like Akshay told you, y square. If you see y square, not a function, because if I isolate y, then what will I get? I will get square root, and whenever I have to do square root, then you'll have plus and minus, correct? So that means I'm associating two values of that x. You get the idea, right? So in this particular case, it will be 1 over x plus and minus. So every value of x will result into two values of y. You get the, do you see this? So very easy that from the equation, if you look at y squared, you can rule out that to be a function. That is one thing. Second, knowledge of graph is very important. Simple equation like x equals to 1 should give you an idea that this is a vertical line, right? Because we have done it over and over from grade 9. So by this time, you should know it. Advanced functions is lot of graphing. So visualize, correct? So as soon as you see an equation, okay, Hamza, try to visualize how the graph is going to look like. That is going to help us a lot, correct? Very good. But it was a brilliant question. And my purpose of putting this was that only, right? So you got it. Perfect. So I think we can move on to question number 2 with this. Can you read? Ankita, can you please read the question?
Consider the relation shown in the mapping diagram, right domain, right range, and then is this relation a function?
We have already answered this question. So what is the domain for this? Ankita?
Wouldn't there be like, oh, you mean like that? Okay.
Yeah.
1, 2, 3, and then A, B, C, D.
Correct. So whenever we are trying to write domain or range, we will write it in different ways. This is called a set, right? So we have actually in this particular case listed the elements. So this is a way of writing domain and range. Domain, we have in this way listed the elements. So we say list, right? We could have also written this in a set form saying that these are the numbers between, let's say, x belongs to, let's say, natural numbers, where x is greater than equal to 1 and x is less than equal to 3. We could have written it in this form also. If I write it in that form, it will be called as the set form. This is the list form where we are going to just list the numbers as such. So this is what I'm going to teach, right? Is that clear to you? As far as function or not, we know this is not a function. It is just a relation. That we know. Perfect. So is this clear? How do we write domain and range? Let me move on to this third question. Now, this is kind of a word problem. So till now in grade 11, you did a lot of functions, some applications, right? This is a grade 11 application. So Hamza, can you please read the question?
A 600-meter fence is used to enclose a rectangular pen area with a partition as shown in the figure.
Yes.
Sorry. Some OCD thing is covering A, but right area of the rectangle is a function of width. B, find the domain of the function, and C, determine the dimension that will provide maximum enclosed area.
So I will say this is our basic question to understand. We want to write something as a function of something else. It's a real life situation. You can say a farmer has so much of fencing to be done and he has some chickens and some sheep and he want to put them. That kind of a word problem will be framed in this fashion, correct? So we have 600 meters of fencing and this is the enclosure. Now, can you help me find the function, please? Akshit, okay. Akshit, can you tell me how do you find function for this? Where we are trying to relate area with the width.
Yes, sir. So first in the question they told us that there's 600 meters of fencing, right? So that would mean like that's the perimeter. So we can connect the perimeter with the area.
Yes. So the perimeter of fencing is 2 length plus 3 width, and the combined thing should be equal to 600, correct? Now, since we want function in terms of the width, we don't want length in our formula, correct? We know the area is length into width, correct? Area is equal to length into width. So from here, we can isolate what length is. So we'll do 600 minus 3w and then divide by 2. And as soon as we do that, we know what the length is, correct? Once you have the length, then in the formula, we can write area as equal to, instead of length, I will write down this expression, which is 600 minus 3w over 2 times width. As you can see on the right-hand side, all the terms in the right-hand side are with w as an independent variable. Now this w will call as independent variable. Area really depends now on the width of this particular function, right? Now since we have written now isolated w here, we'll say area is a function of width. You understand this concept now? So we are, and this is called function notation, which you learned in grade 11. Hamza, is this clear to you?
Yeah, I think it's clear to me, but the three widths, did you use that because you're trying to find the width on the left side, the width on the right side, and the width in the middle too? Is that why you did three?
Yeah.
Three
So
widths?
there are three widths. Therefore, I just labeled the rectangle saying length on the two sides, they are exactly same since it is a rectangle. And the widths will also have the same width. So represented by the variable w. Now, perimeter is sum of all the sides. Let's call this fencing. And so all the fence length, right? So we added all the three here, right? So not the real perimeter, which you only see from outside. It was kind of a fencing plan. We're saying we have a pen which has been, partitioned in between. So to partition also, you need to put a fence. And therefore, we included the third width. Is that clear? Okay. So rest is absolutely clear to you? Now, the critical part here is what is the domain of this particular function? So, Hamza, how can you answer this part B? What is the domain of this particular function?
Domain means all the x values on the input. So
Which is W in this case.
yeah, so which is w in this case. So find the domain of the function, all the possible values of the width.
Yes. What are the possible values of it?
Not really sure.
Okay. Ankita, can you help me in this?
I know you would do x is equal to all real numbers first, but then after that, I'm not sure. I think you have to find like what the length is in order to know the width.
Okay. Akshit, can you help me?
Yes, sir. So when we're finding the domain, right? Like
Yeah.
Ankita said, it would be x is an element of all real numbers, but there would be a restriction because area cannot equal to 0, right? So we would have to
Negative,
expand. Yeah.
Okay. So let me tell you. So basically, if you see this particular factor, which is 600 minus 3w, it could be negative, right? So we cannot have negative lengths or negative area. Therefore, this value 600 minus 3w should always be greater than equal to 0, correct? So if I solve this inequality, I should get this, and dividing by 3, I should get this, correct? That means my width is actually greater than, less than or equal to 200, right? And it cannot be 0. We can say greater than or equal to 0. You get the idea. So we get the domain of this function as width greater than or equal to 0, but less than or equal to 200. So width is in between the two, right? Only then you can have a positive value, or I should say, in this case, non-negative value of area, okay? Of course, if I make width as 0 or 200, in that case, 200, 200, 200 is 600. There won't be any length. Area is going to be 0. But, well, 0 is acceptable, correct? You just put those fencings one over the another. You don't enclose anything. But it's a valid number. So therefore, we will say that the domain of this particular function is width between 0 to 200. And if I want to write it in set builder form, how will I write it? I will say, let me rewrite this because there's less space here. So I'll say, well, the domain of this function, dw, I'm saying, w is my variable, is that w belongs to real numbers so that it is greater than equal to 0, but less than equal to 200. Is that clear to you? Mohammed, are you getting it?
I took in grade 10. I forgot to tell you, I took AP Math, so we did a little bit of 11. So I think this part of functions we did do, like this part.
So you can continue then. That's very good, Mohammed. I'm really happy about it. And you're getting it right. So, Mohammed, be clear. If you don't get anything, just ask me a question. I'll make so simple for you. You will not have any difficulty. Okay? Okay. So let's continue from here. So, Hamza, is it absolutely clear?
Yeah, it's absolutely clear. I think I'm not really good at like application and like thinking question, but I think you made this one pretty clear.
Very good. See, Hamza, the thing is, from where you are coming, I know exactly what you know. So my 1 hour with you is to teach you what you don't know. You get the idea. I'm not here to waste your time or my time. I'm very clear about what I gave, right? So I have selected the questions. If we do even 3 questions which I have selected, you will be able to do all the questions, at least 90% of the questions from your textbook, any textbook which is being followed in your school. You get the idea. That's the beauty of my selection of the questions. You will soon realize. Now, part C is determine the dimensions that will provide maximum enclosed area. Now tell me, how will you find maximum enclosed area in this particular example? Any one of you?
So you will need to make use of the vertex first, right?
Okay. How will you find the vertex?
You can put it into the vertex form, sir, the equation.
Okay, so that's a long process. So second thing, you have to understand the best way of doing it. Anybody else? I think Mohammed, can you tell me? This is a quadratic equation. How do you find the vertex from intercept form? We have x 600 minus 3w times w.
You would get the 2 x's and get the middle.
Excellent. I love it. So it is basically a parabola, which is kind of like this. And the 2 x-intercepts are at w equals to 0. And the other one, we just found it, right? 200, correct? Right? Those are the 2 x-intercepts. And therefore, right in the middle, we have the maximum. So maximum is at x equals to 100, right? Therefore, we'll put 100 in our equation. So we have 600 minus 3 times 100 is 300, correct? We'll divide this by 2 and multiply by 100. Simple as that. So it is 300 by 2 is 150. So 150 and 2 more zeros, 15,000 is the maximum area. And the units are going to be meters square, right? Did I write the units here? Yes, I did. Okay, meter square. Do you see that? We got the maximum, which is the vertex of this parabola, within seconds using the x-intercepts. So whenever you're using a quadratic equation, be aware that we have many different ways of finding the maximum. And so we should use them, right? The most effective one. Very good. Now, maximum also gives you the range of the function. Can you now tell me range of the function? Hamza, I would like you to answer this question. What is the range of this function?
So I did functions a while ago, so I don't really remember, but it can't be more than, so it's going to be y above real numbers. That's going to be.
So y belongs to real numbers so that it is greater than equal to 0, but is less than equals to 15,000, right?
Uh-huh.
Done. And that is why we were looking for a maximum. Ankita, is this clear to you?
Yeah, the range part really confused me a lot, like even in grade 11. So yeah, that became much more
Absolutely clear. Moving forward, we have to go with a very, very sound foundation. So plug all those holes which remains right from grade 11. We have to move forward and remember, it should be an even ground, right? Okay, another good question is right there before you. This is, we have to now understand the matching of the function's graph with the function itself, correct? We have a very interesting function, which is square root of x. Let me tell you something about the square root of x first, and then we'll get to the question itself. So, how will this graph of square root of x look like? Akshat, can you tell me?
Yes, sir. So yeah, it'll look like that. Yeah.
Perfect. So, as you see, the square root of x will be in quadrant 1, correct? Mohammed, are you with me? Square root of x is in quadrant 1. The domain of this function is x is greater than equal to 0, and the range is y is greater than equal to 0. It is in quadrant 1, correct? And it is always increasing. Do you see it is always increasing? As you move from left to right, you notice that it is always increasing. That's the beauty of this function. And it has it is a function because if I draw a vertical line, it only intersects at one point. So it is a function you can see from the graph. Correct. Now, Hamza, do you remember the transformation of functions?
Yes, I remember like vertical, horizontal stretch, translation. I remember.
And reflection. Okay, now this is my function square root of 4 minus 2x. Can you help me explain the transformation of this function first as
I
compared to square root x? Yes, please.
Okay, so I think the 4 is a vertical. I'm not really sure. There should be something outside the back, which I remember as a horizontal vertical translation.
Okay,
Vertical stretch.
we'll move to Akshat. Don't worry, we'll get it there. Akshat, can you tell me the transformation of this function?
Yes, sir. So first you would have to factor out 2 from inside the
Perfect.
root.
Perfect.
So yeah.
Hamza, wait. You can continue, but let me explain this point. So Akshay said first you factor out 2. Do you see this portion 2 here? Let me factor out 2 and rewrite the function. It is minus 2 in fact. So I'll factor out minus 2 itself. When I do that, I get x, and dividing 4 by minus 2, I get minus 2. Is this clear to everyone? Correct. So that becomes the function. Now, Hamza, second chance for you to explain me what is this transformation?
Which transfer? Which one?
Square root minus 2 times x minus 2.
That's a horizontal. That's a horizontal stretch.
Very good. You say stretch. Why? It's wrong. The inside function, whenever you're looking into the function, the inside part gives you horizontal. You are correct on that side. Now, since this number is greater than 1, horizontally it is always in the reverse direction. So it is a horizontal compression by a factor of half. Is that clear to you?
Yep.
Horizontal, let me write horizontal compression by a factor because it gets multiplied by a factor of half. What does this minus indicate? Reflection on which axis?
Reflection on the x-axis.
No, y-axis. It is horizontal. So if you move horizontally, you're basically reflecting it on this side. Do you see that part? It is reflection on this. And when we say that it is horizontally compressed, that basically means that this graph actually compressed means it comes like this. It looks like a vertical stretch. So that is your horizontal compression. And this minus 2 really means move it 2 units to the right, correct? So we'll move it 2 units to the right and it will look like this. So at 2, the graph will move, and that line which I've just drawn will become the graph of this function. Is that clear to you? How I got this transform function. So key points here are, whenever you are given a function as shown here, in that case, factor the x coefficient. Because when you look into the transformed equation, let me now write down, let's say g of x is my transformed equation. It is always written as a times f of k times, let me put a square bracket, x minus, let me use p here, plus q, right? Something like this. Now, whatever is there inside this square bracket, it is basically function and it relates to horizontal, whether it is horizontal, translation, reflection, stretches, or compression. Everything outside is vertical. A means stretch and Q means it is translation up and down, right? Positive value of Q means up, negative down. A, positive but greater than 1 is a stretch. Less than 1 and greater than 0 is a compression. But if I have a negative number there, in that case, that negative number is going to reflect it vertically on the x-axis. So that is the general form, correct? So here you notice that A and Q were zeros, right? So nothing vertical is happening here. Do you see that in this particular equation? Everything in the transformation was basically horizontal, right? It was a horizontal compression by a factor of half and a reflection on the y-axis. So out of these graphs, tell me which one actually is the graph of the function f of x equals to 4 minus 2x.
Sorry to cut you off. What did K represent again?
K is a horizontal stretch or compression.
So the question real quick. I think I missed this.
Which graph reflects this function 4 minus 2x? So K is horizontal compression or stretch, right? So compression, if the value of K is greater than 1, then it is a compression. But if it is between 0 and 1, then it is a stretch, okay? Horizontal stretch. And if K is negative, negative value of K means negative K means it is a reflection on y-axis. Is that clear, right? So this graph has definitely got reflection on the y-axis and it has moved to 2 units to the right after doing a horizontal compression, right? So which one do you think is the right graph? Tell me from the color, plus. Which color?
Sir, I think the orange one looks right.
You are right. So the orange one is the right graph. It has moved 2 units to the right and it has reflected on the y-axis. That is the right. And once you have this in the mind, you can always write domain and range from this particular function. The domain is left side of 2. That means less than equal to 2 and range is greater than equal to 0. Is that clear? Now, Hamza had asked me a very good question. That is how without graphing we could answer this question, correct? It makes sense. Now, very, very important. Sometimes in the test, we are wasting a lot of time just by doing everything. But if they only ask me, what is the domain of this function? What is the easy way of doing it? Well, this particular thing can be non-negative, right? Otherwise, we do not have any real value here. So how do you find the domain directly? We will say, well, 4 minus 2x should always be greater than equal to 0, correct? Because within the square root, I cannot have a negative value. So let's solve for it. So this time I'm taking 4 on this side. Look here. 2x is greater than equal to minus 4, correct? Now, can you tell me the solution hereafter? What is x equals to? Ankita, can you help me out?
X is, sorry.
Yeah, tell me. X is what?
X is greater or equal to 2.
No. You divided by minus 2, right?
Yes.
When you divide by a negative number, inequality has to change the direction. So it becomes less than equal to 2. Is this clear to everyone? Mohammed, do you get this part?
Yeah, we did that in my course.
Correct. So it is very important in inequalities. Whenever you divide or multiply by a negative number, the sign of the inequality also changes. To give you an example, very clear. 7, you know, is greater than 5, right? Correct. If I multiply by minus, what happens? This becomes minus 7. That becomes minus 5. Which is greater?
Minus 5.
Minus 5 is greater. Sign changes, right? Do you see that part? In inequality, remember, that is the difference between solving an inequality and solving an equation. Sometimes that is a communication question. What is the difference between solving inequalities and equation? We see inequalities have many, many solutions, right? Anything less than equal to 2 is my solution, correct? Is the domain in this particular case. Hamza, is this point absolutely clear to you?
Yes, I think
Very
so.
good, beautiful. So now we can move forward from here. We have seen that the graph B, which is the orange one, is what this function is representing. And we have also understood the basics about transformations. But remember, I'm actually going to teach you transformations in the next class, right? We'll go over this again. At this moment, I'm only trying to see where you are, right? What you understand, what you don't understand, and what things I have to keep in mind while moving forward. That's the whole idea. So I'm teaching plus learning from you so that we could go without any hurdles as we move along. So let me move on to another example here, inverse of a function. Now, Hamza, have you done inverse of a function?
Yes, I have.
You've done.
Sorry.
Ankita, have you done inverse of function? Perfect. Now, then in that case, Ankita, can you please read the question and answer the question?
Inverse of the function f of x equals square root x plus 1 is f negative 1 of x equals x squared minus 1. Is the above statement true or false?
Can you answer, please?
Yeah,
Is it true or false?
I think it's true.
Okay. Hamza, can you tell me whether this statement is true or false?
I would have to solve it and see, but what I do first is the f of x, I would turn it into y, and then I try to swap the x for the y, and then try to solve it and see.
Okay,
But
you solve. Akshit, can you tell me whether this statement is true or false?
Sir, I'm thinking it's true also.
All of you are wrong. False. Can I tell you without solving, how do you figure this out, please? Correct? Hamza, I know you will solve it and you'll give me a wrong solution. Correct. Don't worry about it. We will understand why this statement is false. Correct? Everybody thinks this is true. Not you. 90% students in the class will think it is true. Advanced functions is a very tricky subject. When the teacher is teaching you, just as in functions, you think it is very easy, you got it. But the marks, they don't reflect that, right? So you have to be very careful. Now, tell me, what is the domain and range of this function? Square root of x plus 1. What is the domain?
X is an element of real numbers such that x has to be greater than or equal to 1.
Minus 1.
Yeah, minus 1.
Perfect. How about the range?
Y, ER, and y has to be greater than or equal to 0.
Correct. When you do the inverse, what really happens? When you do the inverse, the x and y swap, right? Hamza, as you were saying, you'll swap x and y. That means the domain and range of the inverse will also swap, right? Hamza, am I right? So what is the domain of the inverse function? Tell me. It will be x is greater than equal to 0, and this will be the range, right? So range will be y is greater than equal to minus 1, correct? Because clearly we are going to swap it, correct? So the domain becomes the range and range becomes the domain for the inverse function. Is that clear to you? Hamza, is that clear to you? Perfect. Now if you look at this function x squared minus 1, what is the domain of this function?
All real numbers.
All real numbers. It is not this. Therefore, it is not inverse of the given function. So what is missing? How can I make it inverse of that function? Tell me that.
Does the x squared have to be negative?
X has to be greater than equal to 0. We have to write here comma and give a condition that x is greater than equal to 0. Now it becomes inverse of that particular function. You get the idea. If you want to sketch it, sketch is simple for that. Now, since we know x is greater than equal to 1, we are looking into the right arm of the parabola, right? X square minus 1. So basically, the parabola starts from here and goes like this. Do you see that? And this is the inverse. You can very clearly see that if I draw, let me redraw this neatly. Now we have understood the concept. Okay. Okay, so first graph, this square root of x plus 1 is a graph which is kind of like this. And to get the inverse, what I could do? Well, simply, I could reflect it on the line y equals to x. Correct, Hamza?
Yeah, that makes sense.
Yeah, y equals to x. And in this particular case, if I reflect my line, how do I get it? I get it like this. Do you see that? Only the right half of the parabola. That is to say, x square minus 1, where x is greater than equal to 0. Do you see this now matching? So only the right half. If I drew that, then it is the inverse of the given function. Is this part clear? Got it, right? Mohammed, did you learn about this? We are restricting the domain of the parabola. We are not taking the whole parabola because the whole parabola has a problem. You know what is the problem? Let me extend and show you. The whole parabola will be like this, correct? So if I draw a horizontal line, it cuts at 2 points. So the inverse of this parabola is not a function because it cuts at 2 points of the horizontal line. And that is why what we do is we remove one side to ensure that the inverse is also a function. Hamza, is that clear to you?
Yes, that makes sense. I kind of knew about the domain and range that they would switch. They would switch
Yes.
every time it would be inverse, but I forgot about that.
Very good. No problems. So this summer is a very good time to remember all this, right? So that is how we have actually, in this particular example, learned so many things. I have taught you once again the transformation. How do we sketch a function so easily? How do we figure out the answer just by looking at it? Understanding the concept of domain and range. How is the domain and range of the function and its inverse related? How do we graph the function and its inverse using the reflection on y equals to x? So many things we are getting from this particular screen. Is that clear to all of you, right? Okay. Perfect. So that is where we are. Next example, we'll not take it now, but I'll take a transformation and all these things later on, correct? So I will actually kind of end my class at this moment over here. Now, uh, at this stage, whatever we have done, I've actually taught you today what you have not learned in grade 11, what is important for grade 12 or advanced functions. So therefore, from your book, you can now solve at least 90% of the questions. Do you get the idea? I would like you to attempt that. Did any one of you try some questions from your book or something?
Yes, sir.
Okay, Ankit, Akshat, what did you find?
Sir, in the book, right, I found that they were really like 1.1. It was like prerequisite questions for MCR3U.
Yeah.
And mostly the challenging questions were the extending ones, so like 11, 12, 13, like those ones.
Okay. So can you share your book for a moment? Let's see what book you're following, and can we just go through it in another 5-10 minutes?
Yes, sir, no problem.
I'll stop sharing so that you can share, right? Let me just wait, right? So multiple sharing is already on. Yes, Akshat, can you share your book and let us see what kind of things you're doing, and we'll quickly go through the book and see whether we could do all this or not, okay?
Yes, sir.
Go through the beginning, right?
Yes, sir, this is it, 1.1.
Okay, so we are talking about functions. The very first example, can you please read the example?
Yes, sir. Jonathan and Tina are building an outdoor skating rink. They have enough materials to make a rectangular rink with an area of about 1,800 meters square, and they do not want to purchase any additional materials. They know from past experience that a good rink must be approximately 30 meters longer than it's wide.
Correct. Now, they provided you solution. We had a very similar question, not relating like this, but area of a triangle and with some fencing, right? Perimeter was there. So in this case also, we are given some parameters. Area is given here, and we are given how the two sides are related. Do you see that?
Yes,
So
sir.
area is product of those two sides. You can write down the equation. Since they say one side is 30 meters long, so you can say y equals to x plus 30. And when you multiply width with x plus 30, then you get your equation, and that becomes the area in as a function of your width, correct? And then you can solve it as we did in one of our examples, okay? Let's move on to the exercise, Akshit.
Okay, sir.
Example 1, 2, 3, 4, 5, 6, something like this, questions, right? Okay, I'd like you to wait. Come back. Okay, this key summary. Okay, Akshat, can you read very fast all these key things?
Yes, sir. A function is a relation in which there's a unique output for each input. This means that each value of the independent variable, the domain, must correspond to one and only one value of the dependent variable, which is the range.
Correct.
Functions can be represented graphically, numerically, or algebraically.
Good job. So as they have shown here, graphically, they have shown you a parabola. Numerically, we can also show you in the form of set or ordered pairs, right? So they have, when you list ordered pairs, it is called ordered pairs as they are shown, but we in general call it a list form. We have listed them all, correct? Then table of values. Like when you want to draw a line, you put x and y values, you can represent the function in the table of values. The mapping diagram, which you saw, how do we relate? Very easy and effective way of showing a function. And then algebraic expressions, all the equations which you go through is another way of showing an function. So there are 4 or 5 ways of doing it as shown here. One, which is missing here, is by words. You can write a statement. Statement is a mathematical equation, right? So if I say that a number is twice the input plus 5, it becomes kind of a straight line, right? Any number you say multiply by 2 and then add something, you get your equation. So by words also, you can express the functions. You can add that to your list, okay? Let's move forward. Need to know. Yeah, read.
So, sir, for the need to know, function notation f of x is used to represent the values of the dependent variable in a function. So y equals to f of x. You can use the vertical line test to check whether a graph represents a function. A graph represents a function if every vertical line intersects the graph in at most one point. This shows that there is only one element in the range for each element in the domain.
Correct.
The domain and range of a function depend on the type of function,
Correct.
and the domain and range of a function that models a particular situation may need to be restricted based on the situation. For example, negative values may not have meaning when dealing with variables such as time.
Perfect. You see, we covered all these points in our just 2 or 3 examples. Do you see the beauty? Chapter is over. So this is how I teach. And see, the whole chapter is over. You should be in a position to answer all the questions from this book. Okay, now move on. The very first question is just to figure out whether these are functions or not. So that's very simple. You can always answer, right? Move on to the next part. So these are mapping diagrams. You can say vertical line test for the next one. Yes, move further. Okay, so that is kind of an example of a rectangle which we took, right? Move further. Right, move further. Extended questions. Go to extended questions. Good. Read the question. 14.
Yes, sir. Consider the relations x squared plus y squared equals to 25 and y equals to root of 25 minus x squared. Draw the graphs of these relations and determine whether each relation is a function. State the domain and range of each function.
Okay, Hamza, can you answer this question? When
Yes,
I say
so
x
right
plus y squared equals to 25, what is the graph of this function?
Sorry, so x squared plus y squared equals 25. This actually looks very similar to the equation of a circle.
Perfect.
So if I were to imagine a circle, I don't think I'm 100% sure it would not pass the vertical line test. It would be touching 2 points. If I were to draw a straight line.
Excellent. Yes. Now, y equals to square root of 25 minus x squared. Is this a correct statement for that?
For what, sorry?
Consider the relations, this and the right side, right? So the first one you're right. The first one is not a function since it fails the vertical line test, correct?
Mm-hmm.
The second
Yeah.
one is a square root thing, right? Y equals to square root of 25 minus x squared. Is this a function?
Um, I think it is a function.
It is a function, it is a square root function. Another thing which we
It's a square root
notice,
function, right? It's
when,
like the one we just did.
yeah, whenever you see y square, immediately you can say it is not a function. You don't even have to know what it represents. Is it a, ellipse or a circle or what, right? Y square. If you see y square in the equation, the answer is not a function. Is that clear? That is the key. And we have done extended question within no time. Do you get the idea? Perfect. So now I will request all of you to go through your textbook, whichever you follow, and do all the questions from functions. If you have any difficulty, feel free to just post that question to me anytime. I don't want to wait for our next class, right? Do you understand? Don't sit on the questions. Whenever you get a question, feel free to send it across to me and I will send you its solution or provide you the explanation. You get the idea? I will not wait for your next class. I want you to move forward. Correct? That's the whole idea. That is the way of teaching. And that's what I want you to move. And we have to finish this as early as possible. So before next class, you have to do all 1.1, all the exercise, correct? Next topic here is explore absolute function, which is absolutely new topic for all of you. I'm going to discuss this absolute functions with you. Mohammed, join our class next time. We will learn about absolute function and you will understand. I've seen now what your level is. I'm very glad to see that you have picked up, in spite of not doing functions, today's lesson, right? Did you really get it, Mohammed?
Um, yeah, I thought it was gonna be a lot harder,
Yeah.
but I did AP math. I
Yes.
didn't do a lot of grade 11 stuff, but my course does little bits and pieces from grade 11. We don't do
Yes.
the full course, but we do a little bit.
Very good, Mohammed. Don't worry about it. You just continue with us, and I'll see to it that you understand. Now,